Good morning, dear student. Today I will discuss about the diesel and dual cycle, their efficiency derivations. This is the outline of the today lecture: diesel cycle and the thermodynamic process, PV and TS diagram, related formula based on the basic thermodynamics, thermal efficiency derivation of the diesel cycle, dual cycle, thermodynamic processes used in the dual cycle, efficiency formula of the dual cycle. This is the diesel cycle diagram in which the gasoline engine are the represented and the diesel engine is also represented. The thermodynamic process which are the describing here, the process 1 to 2, that is called isentropic compression, in which the only the air is compressed in the engine cylinder instead of the fuel and air. 2 to 3, that is the constant pressure heat addition, in which the heat addition it is the taking place by the fuel injection process taking place at the combustion chamber at the end of the compression stroke, where the air it is contact with the injected the fuel which is initiated the process of combustion. 3 to 4, that is the isentropic expansion. After that, where the combustion process is completed, there will be a chances of initiated of the expansion process due to the gases expansion. It is taking place from TDC to BDC. 4 to 1, that is the constant volume heat reaction, where gases, exhaust gases, it will be exhausted into the atmosphere. So there are the two types of engine where the differentiating gasoline engine and the diesel engine. Air fuel mixture which are the coming in the engine cylinder, which is called a gasoline engine or the petrol engine, where the spark plug is uh, mounted at the cylinder head. In the case of the diesel engine, where the only air it is the compressed and the injected of the fuel injector by the fuel injector at the end of the compression stroke, and the combustion process initiated by this method, that is called a diesel engine. This is the PV and the TS diagram in which all the process are the showing. 1 to 2, that is called isentropic compression, already discussed in the previous slide. 2 to 3 is the constant pressure heat addition, where the combustion it is taking at the constant pressure process. 3 to 4, that is called isentropic expansion, where the expansion it is taking place after the combustion process. 4 to 1, this is called a constant volume heat reaction. So there are the 4 process. यहाँ पे आपकी 4 प्रोसेस होती हैं कि only the suction, एयर अंदर आती है और एयर के अंदर आने के बाद यहाँ पे एयर का ही कंप्रेशन होता है, जिसमें कि कंप्रेशन रेशियो हाई लिमिट को क्रॉस करता है. एंड एट द कांस्टेंट प्रेशर यहाँ पे हीट का एडिशन होता है ड्यू टू द फ्यूल इंजेक्शन, फ्यूल को इंजेक्ट किया जाता है. एंड 3 to 4, दैट इज द आइसेंट्रोपिक एक्सपांशन ऑफ गैसेस ड्यू टू द बर्निंग ऑफ मिक्सचर due to the fuel injection process is taking place at the TDC point here, and the fuel supply it is cut off there because of the no fuel is supply, because of the combustion is totally initiated at the proper manner. And 3 to 4, that is isentropic expansion, it is taking place when the piston is moving from the 3 to 4, and when the piston is moving from the TDC to BDC condition. This is the isentropic process. 4 to 1, that is called a constant volume heat reaction, where the gases will be exhausted to the atmosphere at the constant volume process. There is a 4 process, that is 1 to 2. It is called a TS diagram. This is called a PV diagram. This is the PV diagram, pressure versus volume. This is the temperature versus entropy diagram. तो यहाँ पे 4 प्रोसेस है. 1 to 2 जो कि आइसेंट्रोपिक कंप्रेशन है. In this process, entropy remains the constant due to the heat transfer is 0. 2 to 3, that is the heat addition is take place, where the temperature will rise. And the 3 to 4, that is called the process of isentropic expansion, where the entropy remains the constant, heat transfer is 0. 4 to 1, it is called a constant volume heat reaction process. It is taking place. So heat is supplying is here, and the heat is a reaction. It is taking place constant volume process. V1 and V2 is called a compression ratio, already discussed in the Otto cycle. V3 by V2, that is called a cutoff ratio. So here 0.3, it is showing the cutoff point where the fuel supply which is cut off. यहाँ पे फ्यूल की सप्लाई को कट ऑफ कर देते हैं. So this is the PV and TS diagram where the thermodynamic processes are explained clearly. This is the related formula based on the basic thermodynamics 1 to 2 process. This is the description isentropic compression, where is the related formula already discussed in the Otto cycle. 2 to 3 constant pressure heat addition, where the heat supply it is taking place of the MCP T3 minus of T2 because of the constant pressure पे वहाँ पे आपका heat addition हो रहा है, इसलिए MCP T3 minus of T2. Isentropic expansion, there is a formula, it is given, and the 4 to 1 constant volume heat reaction, that is the heat reaction is given by MCV T4 minus of T1. Thermal efficiency of the DL cycle, that is describing is here by the formula W net upon the heat supply is equal to 1 minus of the Q out by the Q in. Now, what is the total work done? Net work done, that is the heat supply minus of the heat reaction. And apply the first law of the closed system to the process 2 to 3, where the pressure is constant, heat supply is given by formula that is called W net is equal to that is constant pressure process जो भी आपकी वहाँ पे हो रही है. Because of the change of internal energy, it is equal to the heat transfer minus of the work transfer, and the formula it will be remains unchanged because of the change of internal energy is represented by the formula MCB T3 minus of T2, and this is the work done formula because of the P2 V3 minus of V2 is represented by the MR T3 minus of T2. This is the work done formula 2 to 3 limit PdV, and it is the represented commonly, and the finally Qn is equal to MCP T3 minus of T2. This is the formula for the heat addition in a DL cycle. Apply the first law closed system to a process 4 to 1 where the volume remaining the constant. So if the volume remaining the constant for the 4 to 1 process, the formula will becomes MCB T4 minus of T1. This is the formula of the constant specific heat, and the 4 to 1 process where the heat supply heat reaction it is taking place at a constant volume process, and the formula is MCB T4 minus of T1. So this is the work done formula of this process 4 to 1 PdV is equal to 0. So that's why here the formula will comes MCB T4 minus of T1. The thermal efficiency will becomes 1 minus of the Q out by the Q in, and the formula will becomes here putting all these values of the heat reaction and the heat supply. जितनी भी आपकी heat supply और heat reaction की values put up कर देंगे यहाँ पे. So P4 V4 by T4 is equal to P1 V1 by T1. This is the gas law where the V4 by V1, and after that simplification that is comes to the T4 by T1 is equal to P4 by P1, and the recall the process 1, 2, and 3, 4 that is called isentropic process, in which the formula will reduce and it will be converted into this form. The thermal efficiency of the diesel cycle that is equal to the 1 minus 1 upon compression ratio P power K minus of 1, where K is called the ratio of to specific heat into the cutoff ratio to the power of the adiabatic index minus of the 1 upon that is the gamma or K that is in bracket of the RC, which is called the cutoff ratio minus of 1. So this is the formula which are coming after the simplification in the diesel cycle. This is the standard formula of the thermal efficiency of the diesel cycle, which are the detailing is here. Another cycle that is called a dual cycle, which are using in the high speed racing vehicles or used in the where the partially heat transfer it is taking place of the constant volume and the partially heat taking place at the constant pressure process. So these are the 5 process. यहाँ पे आपको 5 process दिखाई दे रही हैं. 1 to 2 isentropic compression, 2 to 3 is the constant volume heat supply, 3 to 4 constant pressure heat supply, 4 to 5 that is called the isentropic expansion. So these are the process, and finally 5 to 1 exhaust जो आपकी गैसेस बाहर जाती हैं उनके लिए वाली प्रोसेस है क्यू आउट. तो आइसेंट्रोपिक प्रोसेस जिसमें कि कंप्रेशन हो रहा है, एक्सपांशन भी हो रहा है. तो फर्स्टली सक्शन ऑफ द फ्रेश चार्ज जो कि हम हरदम बोला करते हैं, इट इज फ्रेश चार्ज इज कमिंग फ्रॉम द आउटसाइड टू द इंजन सिलेंडर, and 1 to 2 that is a compression of fresh charge is intake into the engine cylinder, and after that the heat addition, partial heat addition, it is done at the constant volume process, and a partially heat addition, it is done at the constant pressure process. And after that, where the combustion process is completed, there is a chances of where the fuel supply it is cut off. This is point the cutoff. This is point the cutoff where the fuel supply it is cut off. And after that, here the expansion is taking place. This is called isentropic expansion. And the 4 to 5 process, that is called isentropic expansion. 5 to 1, there the exhaust process, it is taking place at a constant volume process. So dual cycle gives a better approximation to a real engine. The heat addition process is partially done, which are already discussed in the literature at the constant volume and the constant pressure. From the PV diagram, it looks like a heat addition process is the combination of the both the R2 and the DO cycle. So this is the main fact about the and the differentiate between the diesel cycle, auto cycle. It is different from the both cases dual cycle where the it is a combination of the R2 and the diesel cycle where the both combination it is taking place in the dual cycle. Partially heat addition it is taking place of the constant volume and the partially heat addition taking place at the constant pressure process. So dual cycle where the processes and the description are the given here. 1 to 2 isentropic compression, 2 to 3 is the constant volume heat addition, 3 to 4 constant pressure heat addition, 4 to 5 is the isentropic expansion, 5 to 1 is the constant volume heat reaction. These are the 5 processes which are the taking place. Instead of the 4 process, here the 5 process because of the partially heat addition at the constant volume and partially heat addition taking place of the constant pressure process. So these are the differences. And the same procedure as the auto and the diesel can be applied to the dual cycle. जब सारा प्रोसीजर जैसा कि ऑटो साइकिल में किया था, ड्यूल साइकिल में किया था कि 1 बाई 1 करके प्रोसीजर को पॉइंट को अपन लोगों ने कंसिडर किया प्रोसेस को, और उसके करने के बाद थर्मल इफिशिएंसी जो ड्यूल साइकिल की थी that will come to the 1 minus of the that is called RP is the new factor pressure ratio cutoff ratio to the power of gamma minus of 1 or K minus of 1 upon RP minus 1, that is the pressure ratio minus of 1 plus gamma or K, that is the gamma CP or KCP in the bracket of the rho minus of 1, and the bracket outside of the bracket, that is the compression ratio to the power gamma minus 1. This is the dual cycle thermal efficiency derivation. So thank you. This is the lecture of diesel and the dual cycle and their thermal efficiency. If you have any doubt, please ask me. Thank you.